Okey, kelas. Assalamualaikum warahmatullahi wabarakatuh. So, hari ini kita akan sambung lecture seterusnya. Okey, topik seterusnya adalah bawah topik 4 mengenai the communication model on the parallel algorithm. So we have learned on the design. Kita dah belajar first pasal platform, and then kita tengok what is, and then kita tengok apa yang ada, the current trend in microprocessor, the platform itself, and how it communicates, how to make, so kita tahu parallel processing can be made through multi-computer or multiprocessor. Multiprocessor, a single PC or a single memory with multiple microprocessor. Multi-computer, we have a set of PC, which is each of processor has their own memory and connected together through a communication network. So, communication model dalam parallel algorithm, parallel platform ada dua. There are two ways. First is through shared address space. Second is through message passing paradigm. So, shared address space focusing on a computer that a multi-computer. So shared address space is multi-processor, whereas message passing is meant for multi-computer punya platform. So for today kita akan tengok on message passing paradigm. So what is message passing, apa yang ada, and so on. Okay. So first apa yang kita akan tengok, what is MPI background. The message passing, it is a message passing interface. Bila sebut interface, what is interface here? It's a library actually. It's a library that allow you to communicate between one PC, one processor to another processor. Okay, so bila start began in supercomputing 92, it's a vendor siapa buat IBM, Intel, and then library like IBM. Private virtual machine, application specialist, antaranya ialah national laboratories, universities, and so on. So what is MPI? It's a library, one of the oldest library. Sebenarnya MPI ni ramai provider yang buat. Even Intel has their own MPI, Intel MPI. Ada MPI.net, ada OpenMP. Those are sebenarnya a library for message passing interface that allow a communication between processor and between computer. What is library? Library actually is a program lah. So bila awak tulis, awak buat dalam guna C++, awak include IOStream, include mat.h. So those include apa yang include, you are including a library. So awak include the library that contain a program to operate in certain manner. Contoh kalau awak include math.h dalam C++, it allow you to communicate, to do some mathematical operation without you need to code every single thing. For example, if you want to do a square root, bila awak pakai math.h, awak just panggil the function square root. Tak perlu nak code sesuatu untuk square root function. Samalah, MPI is a library. So why? Right, it's widespread adoption. Portable. Yes, MPI is portable. You can import it anywhere. Ada dalam C#, ada dalam C++, ada Java, ada. So you can use anywhere in any languages. You can use in any platform, OS mana. Okay, pakai Windows boleh, pakai Unix boleh, Linux boleh. It's very minimal requirement on the underlying hardware. Maksudnya, tak ada specific hardware, you just need to import a library, that's all. And however, and it's explicit parallelization, which is, kenapa dia explicit? You have to code it. You have to specify, okay, bila nak pass one message to another, siapa yang nak terima, siapa yang nak ni. It's intellectually demanding. Kenapa demanding macam tu? Sebab you kena tahulah pakai function mana dalam library tu. Bila in part mana dalam kod awak nak guna, and so on. Then, it's achieve high performance and scale to large number of processors. It can communicate, it can allow large number of processes to communicate, tak ada limitation. So, the structure of MPI programming ada 3 lah. Asynchronous, loosely synchronous, and STMD. Asynchronous, however, is hard to reason. Asynchronous adalah secara tidak serentak lah. Okay, secara however it's non-deterministic behavior. Masalah dia ialah susah sikit awak nak determine bila. So ini asynchronous adalah secara serentak, synchronous, yes. Loosely synchronous, dia synchronize tapi secara tak terlalu rigid. Okay, maknanya ada part yang synchronous, ada part yang tak. And usually MPI kita guna dalam single program multiple data. It's very good in functioning bila you ada STMD punya situation. So you can use MPI to communicate the data. So dalam MPI library ada beberapa features. There are several features. Memang semua library untuk MPI mesti ada features ni. Tak kisahlah dia Intel ke, dia point-to-point, Intel ke, OpenMP ke, MPI.net ke, yang kita akan guna MPI.net. Dia mesti ada features communicator information, point-to-point communication, collective communication, topology support, and error handling. So, for example, ini dia punya code send, untuk send dia punya situation, dia akan send apa yang dia nak hantar, number of element, dan juga destination. And then the receiver, dia akan receive, dia akan kena beritahu berapa number of element that will receive. And also the source, siapa yang nak hantar. Okay, MPI have several functions, but there are 6 most used functions. To initialize, to terminate, to determine the number of processes, determine the level of current processes, and send receive messages. The number combine ni dia decide which yang akan dipanggil. And then this is an example of initialization process, MPI initialization. And then it must be called by all processes. For example, ini kita panggil MPI H dalam C++. And then communicator, okay, dia akan decide berapa size and berapa rank, the rank of the processor. So size and rank. Okay, this is example. Okay, this is the correct example. Ada initialize, ada com size, ada com rank. Kalau awak tengok previously, dia hanya ada, tak ada initialization, tak ada, dia hanya proceed dengan sizes berapa. Okay, ini adalah dia punya processor, and ini nombor dia lah berapa bilangan. Okay, and then okay, ini dia punya yang the real one. You have to initialize, decide how many processors and the rank. Okay, and lastly finalize. Mesti ada finalize lah. And the send and receive, this is the function for send. Biasanya dia akan ada dia punya reference apa yang nak dihantar, berapa bilangan, data type, destination, and tagging, and the processor yang akan dihantar. Itulah processor, which processor. And this receive, okay, ada sama, dia akan receive sama bilangan and data type, sources dari mana, tag, and processor mana yang hantar. And processor number and also status. Okay. So there are a number of data types yang ada start, character, and so on. Sama macam programming lain lah. Ini example, send and receive. Example, so let's say we have 2 processors, P0 and P1. Let's say P0 wants to send A, okay, to P1. Okay. So dia akan hantar A, apa yang dia nak hantar. Dia akan hantar juga dari segi bilangan satu sahaja, and also the processor, the destination. And then dia akan hantar A sama dengan 0. So apa jadi yang P1 will receive variable A from 1 only and from 0. Okay, and it will print A. So apa problem dengan what will happen here? Kalau awak tengok dia akan hantar A. Dia akan hantar A. And then immediately apa dia hantar A, bila P0 hantar A, it will reset A equals to 0. And then apa berlaku dekat processor 1, dia akan receive A and will print A. So A kat sini sepatutnya apa? A sepatutnya kat sini adalah 100. However, kita belajar pasal latency. Okay, kita belajar pasal latency and bandwidth. So antara benda problem yang berlaku. So bila send hantar, proses send dia akan ambil masa proses receive. Bila receive berlaku at the same time, P0 akan proceed to the next step. So apa yang boleh terjadi? A kat sini akan boleh jadi kosong instead of 100. Padahal ikut pada processor, dia perlu ikut pada program ni, P1 wants to print 100. That's the problem. So the send and receive process need some alteration. So apa alteration yang dipanggil sebagai blocking dan buffered communication. So blocking dan buffered communication ni macam mana? Okay. So apa yang berlaku? Let's say ada sending and receiving process. Okay. Ini sender come first, idling at sender. So apa yang berlaku? P0 akan hantar request to send. Okay. And then sementara P1 okay, tunggu untuk kata okay, I am able to receive. P0 akan idle dahulu. Okay. And then after P1 is ready to receive, so dia berkata okay, you boleh hantar sekarang. So data barulah P0 akan hantar A kepada P1. So bila berlaku macam ni, processor dia idle kat sini. So P0 akan tak boleh untuk reset A tu kepada kosong. So it will make sure bila dah siap hantar, barulah P0 boleh proceed to the rest task and P1 akan print A sama dengan 100. So ini dipanggil sender blocking dan buffered communication. First type, which is sender comes first, idling at sender. Okay, second type is sender and receiver come at about the same time, which is idling minimized. So yang ini bila dua-dua tu free. Situasi dekat B ni boleh berlaku, tapi kadang-kadang benda tu taklah terlalu realistik. In reality, benda payah nak terjadi. Kenapa? Bila nak tunggu dua-dua processor tu free. So bila processor 0 to request send, dia tu cakap okay send, hantar. Okay, so tak ada idling lah. Yang ni the best lah. However, it's a little bit unrealistic. Dua-dua processor tu free. Second, third part is receiver come first, idling at receiver. So yang ni, the receiver ni dah kena tunggu P0 yang kena tunggu, P1 yang kena tunggu untuk P0 hantar. So dia akan idle tunggu sementara tunggu orang lain untuk hantar. Kes ni macam mana? Contohnya, ini untuk elakkan P0, P1 proceed to the next process tanpa buat apa yang dia kena receive lah. So ini kata handshake for a blocking number for send receive operation. It's easy to see that in cases where sender and receiver do not reach communication point at similar times, there can be considerable idling overhead. So kalau dia memang dapat at same time, yang dapat jadi B lah. Kalau tidak akan jadi idle dekat sender ataupun idle dekat receiver. Kenapa jadi idle? Sebab kena tunggu orang tu free baru boleh entertain. Yang ni kena tunggu. Kalau yang ni kena tunggu receiver ni free baru dia boleh hantar. Yang ni pula kena tunggu sender tu free baru boleh hantar. Baru boleh receive data yang dia nak. Okay, so ini example P0, P1. Okay. So A, yang contoh tadi ni. So, another type of communication ialah blocking buffered communication. Buffered ni apa? Buffered is a small memory. Okay, buffered so A yang ini in the presence of communication hardware with buffer at send and receive ends. So yang ini apa jadi? Okay, yang kat sini ialah ada communication hardware which is ada tukang pegang. So sending P0 dia akan hantar data ke P1. So P1 ni dia tak free lagi. Tapi P0 ni copy dulu dia punya data yang dia nak hantar pada hardware, memori lah. Okay, dekat P1. And then bila P1 ni free, baru dia proceed untuk receive. While in the meantime, P0 dah siap hantar copy dekat buffer, dia boleh proceed to the next process. So bila the case yang previously, dia nak print A, dia akan print A yang di copy dalam hardware, not A yang ada dalam memori. Okay. Yang ini pula B, in the absence of communication hardware, sender interrupt receiver and deposit data in buffer at receiver end. Okay. Yang ni ada special hardware. Yang ni tak ada. Okay. Tapi dia ada buffer. Buffer dalam memori lah. It may be cache and so on. So P0, dia interrupt dulu di P1. Tak kira, kau kena terima dulu. Dia tak terima lagi. Dia tak proses. Dia hanya copy to memory. Letak dulu sementara. Okay, dan so processor dia kena stop dah sekejap untuk receive copy dekat buffer. Tapi tak sampai masa lagi dia untuk receive the data. Sampai masa dia receive the data dan dia akan proceed. So itu adalah blocking buffered communication. Okay. So send receive, kita ada send receive function. So this is send receive function dalam MPI. And dia ada I send, I receive, which is non-blocking. Okay, and there are the test and wait. MPI test if operation is finished. So bila nak hantar, you can tahu bila finish to proceed. So at MPI ada function test. And wait blocks until operation is finished. So kalau wait, function wait, dia akan tunggulah sampai operation tu finish. Okay. Ini non-blocking and non-buffered communication. So biasanya non-blocking and non-buffered communication, dia kena pakai function wait and test and wait. So yang ini without hardware support, and this is with hardware.
So this is non-blocking and non-buffered communication. So how to make them communicate? Usually it uses status. Okay, status is used to indicate the completion of send and receive process. So instead of using blocking, if it is non-blocking and non-buffered, we can use a status function to indicate either the send or receive is complete. So here, we can look here. There is status and there is a send and receive. Okay, the condition is modular. If modular equals to 1, it is out number. It will proceed as it will send B, receive B and send A. However, in this situation, deadlock may happen. Detail on this may refer to textbook chapter 6 on the explanation how the deadlock may happen in this code. So how to solve it? You can use MPI send receive functions. There is an MPI send receive function which the function will control send and receive. Compared to the previous slide, the send and receive is a separate functions. So in this situation, deadlock mungkin berlaku bila the looping, the sending process, the receiving keep waiting for the sending and sending waiting for the receiving. So there is a processor who is waiting for the sending process, and there is a processor who is waiting for the receiving process. So the deadlock may happen that. Okay, so we can use it. We can eliminate the problem using send receive function. This doesn't suffer from circular deadlock problem of MPI send and receive. So the mating of MPI send and receive as following, allowing data to travel from both send and receive simultaneously. Okay. Another function yang ada dalam MPI library is function for synchronization. The first function for synchronization apa untuk to allow or a function that assists a parallel processing. Okay, first is MPI barrier. So the barrier synchronization operation is performed in MPI using the MPI barrier function. So this function will allow the synchronization process running smoothly. So another function is collective communications, which one instruction is there are several types of collective communication, one to all to one, and so on. We are going to one by one. For example, function broadcast will allow one processor to send to several processors similar broadcast a message to another processor. And then scatter and gather. Scatter means we want to make the message scattered. Okay, let's say we have P0 here with message A, B, C, and D, and it will scatter all the message to all the processor. And gather function is to gather all the information into one processor. Altogether, you can see the example. This is an example of altogether. Okay. And then all personalized in this function. If you notice here, it will personalize the which processor will receive which type of data. So kalau tengok kat sini, P0 akan tengok A0, this is example only. B1 will receive A1, B1, C1, and so on. The reduction, it will reduce a number of processors. So let's say we have 4 processors, we reduce it to 1. Okay. So the operation, there are a number of operations ada dalam MPI libraries. These are some, sorry. These are some operation yang ada, minimum, maximum, and so on. Ada all reduce, function all reduce, but apa beza, but all processor receive the result of MPI operation. So ada prefix scan, MPI name, another function is topology. So MPI also provide function to evaluate the performance of MPI. So there is an MPI wall clock time. So it will calculate what is wall clock time, the overall processing time. There's a wall clock time. So this is an example of how we can solve a problem and run it using MPI, and run it parallelly using MPI. So okay, that's all. Thank you. Salam.